module, part 7, which is average rate of change. We're going to start with part 1, which is talking about rate of change from a graph, and then part 2 will be rate of change from tables and equations. So the thing we need to know is the slope formula, and this is the same typo that was on our graph here. The slope is rise over run, or the change in y over the change in x. Okay, so y2 minus y1 over x2 minus x1 when you're given some points. Now, we've talked about average rate of change when we did slope back in module 4, I believe. 4 or 5. Or I think module 4. So we've done slope before. All it says to do, we're just going to review. It says find the average rate of change for the graph below. So when I have a graph, I think personally that it's easiest to find the rate of change by just, especially from a line, rise over run. So the interval here says find the rate of change on the interval from x is 0 to 3. So that means I'm going to start where x is 0, and I'm going to find the slope between 0 and 3. Well, to do that here, it looks like I'm going to go down 2, right 3. So my rate of change would be negative 2 over 3. On the next interval, I'm going from x is 3 to 6. So I'm going to start at x is 3, go to x is 6, and I'm going to count the slope again. Down 2, right 3. That should not be unusual because it's a line here, and we'll talk about that in a second. Lastly, I'm going to find the rate of change from 0 to 6. Now over the whole interval, So looks like I'm going to go down 4 over 6. So negative 4 over 6, which simplifies to negative 2/3. Well, what do I notice about all those slopes? They are the same. Which is a good thing because we should know that the rate of change of a linear function is constant. Which means it's always the same no matter what interval you take the slope over. That's why over all 3 of those intervals, even though I used different values, I got the exact same rate of change or slope. Now, I have to find the rate of change for nonlinear functions because in real life, most things are not represented by a line. So we're going to find the rate of change between the following intervals. And I'm going to show you how to do this in 2 different ways. The first way I'm going to do this, it says between x is 0 and 4. I'm going to use the slope formula. It doesn't matter. It says you pick, here it says to pick 2 points and find the slope formula. I guess we'll do that way because I think on the back we're going to change our method. So from 0 to 4, we're going to remember the slope formula here. It's 0. I have the ordered pair is 0, 1. So I'm going to write the ordered pair here, 0, 1. And at x equals 4, there is a dot on the line there. You're going to go up to 1, 2, 3, 4, 5, 6, 7. So I'm going to find the slope between those 2 points. So I need to know my x's and y's. And the slope here would take, I'm going to start with 7 minus 1 over 4 minus 0, which is 6 over 4 or 3 over 2. So the first interval has a slope of 3 over 2. I'm going to look at the second interval. I already know the ordered pair for x equals 4. That's 4, 7. I found that point. And the ordered pair at 7 looks like it's here. 8, 9. Looks like it's at 7, 10. Okay, so I'm going to find the slope between 4, 7 and 7, 10. So I will have 10 minus 7 over 7 minus 4, which is 3 over 3, which equals 1. So the slope on that interval between those 2 points right here is 1. Finally, do my last point here. I'm going to start at 7, so the ordered pair was 7, 10, and go up to 13. So that'd be 7, 13, 11, 12, 13, 14, 15. And so the slope would be 15 minus 10 over 13 minus 7, which is 5 over 6. But what do I notice this time? I had a curvy line. I noticed that none of the rates are the same. So the slopes or the rates are not the same, which is a little different, but not bad. So what can be said about the rate of change of a nonlinear function? Well, because it's not the same, that means it's not constant. So I cannot pick 2 points and guarantee that the rate's going to be the same. But I also can tell that it's not linear because they're different. Now that wasn't hard, but that was annoying, right? I had a graph, and I had to use the slope formula a bunch of times. So when you flip your paper over, you should see this is the same graph, but now it says draw lines connecting each point to the next. Okay, so like right here, I have a point from here to here. These are the same points as before. If I draw this line here, it says, what do I notice about the slope or the rate of change of that line? So let's count. The slope is up 1, 2, 3, 4, 5, up 6 over 4. And 6 over 4 is equal to 3 over 2, which just happens to be the rate that I found on the front. From 4 to 7, if I draw a line, the slope here looks like I'm going up 3 over 3. And 3 over 3 is 1, which again is what I computed on the front. Finally, I start at this point. I'm going up to the top here. So my line connecting, my slope of that line is going to be 1, 2, 3, 4, up 5 over 6, which I know, I didn't write on the line, is the same rate that I found. So it turns out that, one, when I have a graph, I can find the rate of change by just counting rise over run between the x values. And two, this shows me that the rate of change for a curved line is equal to the slope of the line connecting the dots of those endpoints. Right, there's some practice on the bottom here. Go ahead and give those a shot. You can use rise for fun, and then we'll go on to tables and equations.